All right, since everyone thought that was so splendid and had no questions, we'll just kind of move on from this topic to do some examples. So we're going to start with 11.30, and this is on page 644. And I didn't give you a lot of room. Hopefully we'll be able to squeeze things in. Oh, I'll use this one. So in this question, it says in a randomized co-op comparative experiment, they're checking the effect of calcium in the diet on blood pressure. They divided 54 healthy white males at random into two groups. One group received calcium, the other placebo. So they don't really know if they're getting calcium or not to try and eliminate any effects that way. At the beginning of the study, the researchers measured many variables on the subjects, and the paper reported the study giving X bar 114.9, and S of 9.3. So both of these came from the sample. This was for the seated systolic blood pressure of the 27 members of the placebo group. So I'm going to make a note of that this N was for 27 people. And seated systolic blood pressure helps us to interpret what it is we're measuring. Does anyone know if systolic is at the first or the second number in the blood pressure? No, there's like systolic and diastolic or something, and yeah. Anyway, this is one of those numbers. All right, so part A. Give a 99% confidence interval for the mean blood pressure in the population from which the subjects were recruited. So we want a 99% confidence. Well, we're going to start with the mean. That's our estimate. And then we plus or minus our margin of error. Now, in this one, we did not know the population standard deviation. So we would say over here, sigma is unknown, which means we're going to use what distribution? T. We're going to use T. And so we want T star for 90 what percent? 9. And we want degrees of freedom. How many? 26. Good. So we can do that using our inverse T function. We'll go into the calculator here, into distributions. We want inverse T. And we want the area. Now it's 99%, but we want cumulative. So there'd be 0.995. Very good, yeah. Because this is going to be one-sided. And 26, correct? Yeah. So this is going to give us the t-value that should be correct. 2.7787 or 2.78. We'll use 2.78. So that's the number of standard deviations for our sample mean. And then we need to look at what is the actual standard deviation for the sample mean. So I have two things. What would go on the top here in the numerator? Yes, our S value, 9.3. And then what would go down here? You got it. So we're left to calculate that. So we will take 114.9, and first I'll subtract 2.78 times 9.3 divided by the square root of 27. $109.92. Let me know if you get anything different. And then if I typed all that in, I should be able to just go back up on my calculator to that line, hit enter, and it will repeat it. And then I'm just going to scroll back and change that to a plus. 119.88.